Welcome back to CCNA. We're going to be going over how to subnet. I'm going to walk you through kind of a mock problem out of the lab 1166. So these are not actually problems on the lab. That's because I want you to make sure that you're practicing. That's the whole point of this exercise, is to make sure that you're practicing and you're getting a grasp on how to do this and how all this works. So I've got some given info here in black. And that's what we're given when we look at these problems. And then we have blue here for all the different answers. So I'm just going to jump right in. I'm going to move pretty fast, but if you want to slow down this video, you can with YouTube. You can also replay it over and over again to make sure you have a grasp. Or feel free to reach out and ask any questions. I'm happy to help. So first thing we're going to do is we're going to take this host IP, we're going to take this subnet mask, and we're going to get the network mask of this current network, because I want to walk through this process first. Now, we don't need that for any of these answers, but I just want to walk through that process super quick here. We're going to take the host IP, this 172.18.24.8. I just made this up off the top of my head. It's a random number. I didn't practice this. I didn't exercise this. So if I'm a little slow or I get caught up at any point, give me a little bit of slack here. So and my point with that is to just say, hey, you can do it with any address. You can figure it out. Once you get the flow of it, you can just pick an address that maybe you're working with in the real world, and you may have to do this. Maybe not exactly this, right? But you may have to do some subnetting, which is some form of similar steps and process to come up with a conclusion. So jumping in here, we have this, and we have this network mask of 255.0.0. Okay, so the first thing we want to do, this is super easy. There's just 255s. There's no 128s, 192s, 224s, none of that kind of more complicated stuff where you have to jump in the binary yet. So we're going to take this an easy way. We're going to say, here's exactly where those binary bits stop. So in binary, those subnet masks are all ones from the left until they start zeros. There is no 0, 1. It's ones and then it's zeros. And that's it. So there's a clear dividing line here because 255 is all the ones available in those 8 bits we have per octet. So it's super easy to go and determine the network mask here. That would be 172.18.24.8, right? So when we start doing our ANDing process, and we can do this in binary, and I'll walk you through that in just a minute. But basically, all these are zeros on this side. So our ANDing process, we can just skip that basically and go to all zeros. Now again, we'll go through the proper ANDing process in just a moment. I just want to show you the easy way you can take some kind of shortcuts. Be careful, make sure to check your math. You're in a learning phase, right? So I don't want you to take too many shortcuts, but be aware there are some shortcuts out there, and you guys can go ahead and use them, but make sure to check your math and make sure you're actually doing it correctly. Because a lot of times, if you get caught up doing only shortcuts and you don't know the long math, it sometimes can get confusing, and then you end up in a situation where you're not actually understanding what you're doing. And the whole point of this exercise, again, is to understand how this works. So we've got our network mask, or excuse me, we've got our network address that we're starting with, this 172.18.0.0. So now we're going to apply this new subnet mask, this 255.255.192. So the way we're going to do that is we're going to take our 172.18.0.0, and we're going to take that and we're going to convert this into binary. So when we're talking about binary, it's a little easier to put this in kind of a little graph form. So we're going to take power as a tool, 2 starting with 1. 1 is 2 to the 0th power, 2 to the 1 power, 2, 2 to the 2 power, 4, 2 to the 3 power, 8. And if you don't see it already, we're just multiplying by 2, right? So you multiply the last number by 2. You multiply 1 by 2, you get 2. You multiply 2 by 2, you get 4. You multiply 4 by 2, you get 8. Super easy. All you have to do is multiply by 2. That's all binary math is, multiplying by 2. So if you multiply by 2, you can do binary math. So now we're talking 16, 32. I know I'm going fast. I memorized these numbers. I've done it a million times. So don't worry if you're a little bit slower. You're thinking, okay, 16. It's okay. It's okay. You're in a learning phase. Then we go to 64, 128. That's where we stop. That's 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Those are our 8 bits in our octet. So I'm going to go ahead and put some lines here to hopefully help you guys visualize what is going on here. And we're going to start converting these things into binary. So the way we're going to do that, we're going to take this address, 172. We're going to try to subtract the largest number that we can, 128. And in this case, we can subtract 128. So I'm going to put a 1 here because that bit is turned on. We're going to go ahead and minus that 128. And we're going to take that, and that is 44. Am I doing that math right? Let me check my math. 160, 172, it looks right. 44. Okay. So now can we subtract 64 from that? Well, no. Okay. So we're going to put a 0 there. Can we subtract 32? Absolutely, we can. Go ahead and subtract 32. What do we get? We get 12. Okay, well, can we subtract 16 from 12? Nope. That's a 0. We can subtract 8 from 12. Yes. Okay, so minus 8 starts making a lot more sense, hopefully. Subtract 4. Now we have 0. Perfect. That means we can fill in zeros on the rest of them because we're not subtracting anything else. Now we just converted that 172 into binary. Now we're going to take 18, which is our next digit. We're going to convert that into binary. So I'm just going to erase this so that hopefully, again, you can always go back in this video, the power of technology. You don't have to wait for me. You can speed me up. You can slow me down. You can, move me back and forth. You can always go back if you missed something there. 18. Right, we can run through the same process. I'm going to skip through this super fast because I know I can't minus 32 I can't subtract 32 out of 16. So I'm just going to put a few zeros here. And then I know I can get rid of 16 out of there. I know I've just got 2 left because I've done a lot of math in my life, and this is 18. I'm just going to put the numbers here on the side to hopefully help you kind of get a grasp of where these numbers are coming from. Now, the rest of them are zeros, right? So that is super easy. It's just a bunch of binary zeros. I'm not going to write it out long form just to waste time. I'm just going to move on. All right, so we've got this, and I'm going to write all this out. So 1, 0, 1, 0, 1, 1, 0, 0, dot, because that dot, right? This is the same dot. I'm just expressing it in binary format instead of decimal format that we're used to. And then 0, 0, 0, 1, 0, 0, 1, 0. And then I'm just going to put a little squiggly line because that's all zeros. I don't want to have to worry about that. Okay, so now we're going to take our new subnet mask and we're going to convert that into binary. Now I'll tell you a super easy trick here. These 255s, they're all ones. All 8 of those bits are ones. So I can go and I can just go 1, 1, 1, 1, 1, 1 dot 1, 1, 1, 1, 1, 1, 1, 1 dot. Okay, well now we get into the kind of funky spot. We got the 192. So how do we convert 192 into binary? We do the same process. Right? So I'm going to extend this down a little bit. Can we take 128? Yes. Okay, you take 128 out of 192. What do you get? You get 64. Okay, well, 64 minus 64 is 0. Which means the rest of these are going to be zeros. Again, here's a trick with subnet masks. They're all ones on the left side. As soon as you start zeros, there's no more ones. And so this is the dividing line. That's what this is in binary, is a dividing line. So now you have 1, 1, and then all zeros. So if we start doing the logical ANDing process, goes like this. 1 and 1 is 1. 1 and 0 is 0. 0 and 0 is 0. 0 and 1 is 0. Basically anything except for 1 and 1 is 0. So 1 and 1, draw a line here, is 1. 1 and 0 is 0. 1 and 1 is 1. And we can go through this whole long process. Because this is a subnet mask, this is easy because it's all ones up until a certain point. So we're going to say that all the numbers up until the subnet mask stops, which is inside this octet here. I'm going to put it between the 0 because there is part of that, those 2 binary digits right there. But we know that these 2 octets here, this 172.18, That's all ones in the subnet mask, so that's going to stay the same. The only thing we need to worry about is the first two binary digits on that third octet. And we know that they're both zeros on that side, so they're going to go ahead and just be zeros. That made that super easy. Now we'll go through that again when it's not so easy, and hopefully if this didn't help you get your head around it, the next time you will. So now we've got our new subnet mask, but what does that mean for our subnet? Because we've taken this large subnet, this is a /16 if you're using CIDR notation. This would be a /18. Now, what that means, these slash numbers, that 16, there's 16 binary digits that are ones in the subnet mask. Again, they're all in a row, they're all on the left side, there's no mixing and matching like this, so it's a little bit easier. 18 just means there's 18 binary digits turned on. That's these 8, and those 2 that are outside in the third octet. So, okay, hopefully we got that going. We're getting a light bulb going. We're getting a little excited maybe. Okay, so let's actually get into what actually changed here. And let me start erasing a little bit of this here. So when we start talking about subnet bits, okay, well, how many subnet bits did we add? Okay, well, in reality, we have 18 subnet bits. We added 2. So we're going to put 2 here. Now, depending on how you look at it, really there's 18. I'm going to put it in that way just to kind of make sure that I'm covering all my bases, and hopefully you're able to understand what's going on. So there's 18 subnet bits total that we're using, but we borrowed 2 of them that were previously not part of the subnet mask, right? So we've added 2 subnet bits. So how many subnets did we create inside of this subnet? So what we've done now is we've taken this larger subnet and we've broken it up into smaller subnets. So the way we can do that is we can take this number of borrowed bits, and we can use it to the power of 2 to find out how many subnets we've created. So 2 to the power of 2 is just 2 times 2, right? Again, all you have to do is multiply by 2. So if this starts getting scary, if this starts getting, 2 to the power of, let's just say 6, then you can just write 2 times 2, that's 2, that's 3, that's 4, that's 5, that's 6, right? Okay, well now this is a lot more achievable. And I can go, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 6 times 2 is 32, 32 is 64. And you might not do the math that fast. That's just because these numbers, like I said, I run through them a million times. They're like second nature to me. And so 2 to the 6 is 64. Okay, that's a weird way I do math. Don't worry about that. If you multiply by 2 easier a different way, totally fine. If you have no idea what I just did, that's also fine. So it's just 2 to the power of 2, which is 2 times 2, which is 4. So we've created 4 subnets by borrowing 2 bits. Okay, so how many host bits do we have left? So we can do this a few different ways, depending on how much you enjoy math. So the one way we can do that is we can count bits that are left as zeros in the subnet mask, right? So I can say this whole octet, the last octet is all zeros, that's 8. And then this one has 2 bits that are turned on in the subnet mask, so we have 6 left there. And I could sit there and count them if I want. If that's a little bit easier for me, that's totally fine. There's nothing wrong with that. Again, I'm a big math person, so I'll say, 8 and 6 is 14. All right. Another way you can do that is there's a total of 32 bits that are available. So if you know that you have a /18, you can go take that, subtract that from 32, and then you end up with that 14 number. So we have 14. I'm put an underline there so I don't erase it when I go to. I should just erase this. I don't know if I should erase this. I should keep that. All right, so now we talk about the number of hosts. Okay, so how many hosts are available? This is a little more complicated. We did this math with how many subnets were created, and that's great. It's a little more complicated with hosts. So it's similar math though. So what we're going to do is we're going to take this. Again, it's just multiplying by 2. So it's 2 to the power of how many host bits we have left. That's not it. So wait, don't stop the video and do the math. And do the assignment and finish. That's not it. There's more. There's another step. But we're going to take this and we're going to say, okay, we have 14 host bits. So it's 2 to the power of 14. Hopefully that's not too overwhelming for you. 2 to the power of 14, again, it's just 2 times 2 times 2, etc., etc., right? So we can do that. So, 2 times 2, 3, I can't write and talk at the same time. 4, there's 5, there's 6, there's 7, there's 8, 9, there's 10, 11, 12, 13, and there's 14. Whew. Oh, that's a lot of 2s. So I'm going to do this in my head because I don't want to scare you. Again, if you do it on paper, you do it a different way. It's totally fine. As long as you do the math one way or another, totally fine. So that's 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. That's where I start falling off. 4096. Okay, so 4096 times 4. And I'm going to do that because I can't do that in my head anymore. That gives me what? 16, 19, 27, 36, 30, and then 6 is there, and then 12 is 24, 16,384. So I'm going to actually do that on a calculator real quick, just to make sure if my calculator will pop up. So I will go 2 to the power of, and I might have to make it a scientific calculator. 2 to the power of 14. Make sure I don't look like an idiot. 16,384. Great. Okay, every once in a while I get my math right. So I've done binary math incorrectly in front of a large group of students. It was super embarrassing, and I'm here to tell you that it's okay. It happens, even to the people that do binary math all the time. So don't worry about it. So we've got this humongous number here, the 16,384. Now that we've got from this, of course I had to pick a bizarre example. So now we're going to take that number, that 16,384, and we're going to minus 2. Now, why in the world do we minus 2? That's a weird thing. I was just arbitrary. Like, there's always 2s. Why is it always 2s? So we minus 2, and that's for these two things right here. This network and this broadcast address, we're actually going to have dedicated an IPv4, so we can't use those for hosts. So when we're talking about total number of addresses in the space, there's 16,384. We've dedicated in the IPv4 standard 2 of those addresses to network and broadcast. So we're going to take that, we're going to minus 2. So the number of hosts we have is 16,382. Hopefully you can subtract 2. Not super hard. So now we've got the host number. Okay. So what is our network and our broadcast address? Now the network address is the first address in the subnet. So that's typically how we would write our subnet addresses, right? So we've already done that when we took this, and our new network address would be this 172.18.0.0. And if you don't remember, that was that whole ANDing process. We take the subnet mask, the IP address subnet mask, and do that ANDing process. So now when we talk about our broadcast address, so what we do there is, yep, okay. So we actually take we take all the bits that are after the subnet mask bits, and we turn those on. And so what that does is it gives us the highest IP address in that range, which gives us our broadcast address, which is dedicated to broadcasting traffic. Now, of course, if it's a /24, it's super easy. It's 255, right? The last octet is 255. That's kind of our easy button there. Sometimes people get a little confused. I had a situation where we had subnets larger than /24, and so there was an IP address that ended in 255. Now, some people got in their head that 255 is a broadcast address, which is not always the case. We actually had .255 usable in our address range because of the way that we subnetted. It is very difficult to get people kind of out of that rut that they had been used to for years and years and years because they didn't understand how this works. And they didn't have to for their job, and so they got really confused when .255 was a usable address. So what we're going to do here is we're going to take and we're going to find this broadcast address. So we did this logical ANDing, and I'm going to erase some of this here. So we came up with that is not aligned right, but 172.18. I'm not going to put it in binary for this part because this is all covered by the subnet mask. So when you start converting into binary, these two binary bits that are in the subnet mask are going to be turned off, right? They're going to be zeros. So on is 1, off is 0. Hopefully I didn't confuse you too much earlier. I know I started using that without explaining it. So now those two bits are going to be off. Now all the other bits after that are going to be on. So there's 6 ones, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. Like I said earlier, 8 bits is 255. Super easy, right? We don't have to do the math. So 172.18. I'm going to skip this part, and then I'm going to go 255. Okay. Hopefully that makes sense to you guys. That's because this octet here is all ones, so it's going into 255. Now this next one is not. So we can figure this out one of two ways, again, depending on how comfortable you are with math. I'm kind of weird. I usually take 255 and I take these bigger numbers out. I know these two bigger numbers that we have here equal 192. And you can tell that actually by the mask here. So if you want to really confuse yourself a lot, you can take this number and remove it from 255 to get your middle number there. So we can go 255 minus 198, 192. Yep. And we can go ahead and get that, which is 63. Okay. And yes, that would be correct, because the next bit would be the 64th bit. By the way, weird thing in binary. So if you take this and you take all of the numbers after it, they will equal this number minus 1. So it's kind of one of those weird multiple by 2 things. Hopefully I'm not super confusing you. Probably am. I'm probably going way out of the on left field here. But one of those kind of like tricks that I apparently forgot until just now was that, if you know, hey, this is the bit that we're stopping at, take away 1 from this, and that is the sum of all the bits to the right. So we would have 63.255. Now, kicker here is now that we have this address, the broadcast address, really easy to find the next network address, because we've chopped up this network. Let me try to draw this out, maybe hopefully help you guys understand this a little bit better. I hope this marker is going to work. I haven't tested it before this video, so if it doesn't work, it's going to be super embarrassing. But here I'm going to draw this subnet, and we're going to call this 172.18/16. I'm not going to put the rest of it because it's not part of the network mask. It's not part of the actual subnet. That's just 0, so I'm just going to leave that off. It's a nasty habit of mine. Anyway, so we've got this /16 address. So what we've done is we've created 4 subnets, remember? So we've got 4 subnets going on. So basically what we're doing is we're taking this address space, we're chopping it up into 4 parts. Now, if I wanted to try a different way of displaying this, maybe I could chop it into 4 parts this way. And so now what we're doing here is, say we start here at 172.18.0.0, and over here is 172.18.255.255. Okay, so that's the very end here, and that's the very beginning here. Okay, so now this is our network address, right? For our first network, we talked about that. Now here, this address, this 63.255, is the end of that first subnet. So the next one is the next address available. So if you go and do the math, you'll find that the next way we can increase this from a binary perspective is to make this 172.18.64.0. So what we've done essentially is we've added 1 in binary, which the only way we can do that without including all this other stuff in here is just shift all those binary bits up, essentially. So now what this looks like in binary, hopefully let me show you here. The purpose of that was, hey, where this ends, the very next address is the new network address. So what I'm hopefully going to show you guys is if we take this in binary, so we've got 172, which is 10101 dot 00010 dot. So that's our first 2 octets, right? And these are all ones, and I'm not going to put the right amount of ones because I don't care. But we're going to be focused on this octet here. So in our subnet mask, we've got these 2 bits on. Okay, another networking subnetting trick here is the first network is going to be both zeros here. Now, once we get to this side of the line, where all zeros, 5, 6, where we have all zeros on the subnet mask side, over here, it's all zeros is our network address. I hope you guys can see that. Probably not, it's pretty small. And then all ones would be our broadcast. And I'm just going to put broad on there. And you probably can't read that anyway because it's super tiny. But so we have the all zeros, which is the network address, and then the all ones, which is the broadcast address. Okay, so how do we determine which network this address is in? If it's in this network, if it's in that network, or this or that one. Okay, we have to have a determining factor. Now these 2 bits right here are the important bits when we're talking about what network it's in. Now that's super tiny. You probably can't see that. Should I move this forward? Will this help? Maybe a little bit? Okay. So what we do here in this little section here is the next network is going to be a 0, 1. So that's actually, I know you can't see it because I didn't draw this, but that's the 64th bit. And that's why we have this 64 here, because now that 64th here bit is on, and then whatever's after it could be all zeros for the network address, could be all ones, and I could do the math. I think that would be 127, right? Because we're right before this bit. And the reason I know that is because the next way to go up in these binary bits is a 1, 0. Okay, so it's going to turn on this 128 and turn off that 64. And then we have a 1, 1. So recapping what we have right there, those 2 bits that we're borrowing are going to be the bits that determine which of these 4 networks that we're in. So our options with those 2 different bits are 0, 0, 0, 1, 1, 0, and 1, 1. That's the only binary options we have with 2 bits. Those are our 4 networks. 1, 2, 3, 4. Bam. That's how it's done in binary. Now this is already taking like 30 minutes, so I was hoping this would be short, but apparently not. And I haven't even finished one example. So the first and last host address. So we can't use the network and the broadcast address, obviously. So we'll just add 1 to the network address, the 172.18 0.1, and then the last address, or the host address, last host address I should say, is going to be that 172.18. What did we have down here? 63.254. That's because we can't use that broadcast address, that last binary digit 1. Now, if you want to do the binary math, you can do that. That's great. You can go to this last one, and you can take all these bits on this side, fill them all with ones, and then just take away the last one, which is that single ones place, right? So that would -1 effectively from your broadcast address. So I took a long time doing that first example. Let me try really quickly doing that second example in a little quicker fashion without so much explanation. So hopefully you guys kind of get that in your head a little better without so much fluff and junk and all my mumbling here. Almost there. All right. Okay. You got this all tens address. I love tens. So you got this all tens address. We're going to take that. We're going to put that into binary. So 128, 64, 32, 16, 8, 4, 2, 1. Bam. Really should have made that longer. Okay, so 10 is super easy, right? It's just 8 and 2. Again, I'm just going to go super fast because you guys can slow me down. So it's actually going to be a repeat for all of these octets. So it's super easy, right? So we'll go 1, 2, 3, 4, 1, 0, 1, 0, dot 1, 2, 3, 4, 1, 0, 1, 0, 1, 2, 3, 4, 1, 0, 1, 0, and then 1, 2, 3, 4, 1, 0. Okay, so now we're going to do our logical ANDing to get to our subnet mask. We'll use our subnet mask to do our logical ANDing. Now I'm going to go ahead and use this new subnet mask so we can just go ahead and get started. I know from here that 128 is just that single bit. So we've got one subnet bit. I'm going to put the numbers at the top here because I didn't make any room for myself because I didn't think ahead. But here we go. So the number of subnets created with 1 bit, how many options do we have? A 0 and a 1. There's just 2. So we could do the math, right? We could say, oh, okay, well, 2 to the 4th power is 2. Okay, so we have 2 subnets created. Okay. Host bits. Okay, the host bits are everything on the right side, all those zeros. We have 7, right? Because we borrowed this 1 bit, we have 7 left because we're in that last octet. Just 8 bits we're playing with right now, so we've got 7 host bits. And let me make sure that you guys can visualize that because I don't want to go too fast. This is the subnet mask, the last octet. I just want to, we're just looking at this last octet. All this is all ones. I'm not going to worry about it for the moment. It's all going to stay the same. I'm just worried about this last octet. I could do this math, but it wouldn't give me a different answer. So this 1 bit is going to be a subnet bit. So that's going to create our 2 subnets because 2 to the power of 1. These 7 bits here, these are going to be my host bits. All right. So how many numbers of hosts do we have? You can pause this video, you can do the math if you want, or you can just watch me do it, and then you'll get to do the assignment. So you should get some practice. So when we talk about host bits, right, 2 to the 7th power, just for the sake of time, I am going to do the math here on a calculator. 2 to the 7th is 128. So we have 128, but we don't get to keep all those bits. We have to -2. So we to -2 there. So we'll get 126 hosts available. All right. Now we talk about network and broadcast address. So let's go back to our binary here. So you'll see our first 3 octets I'm just going to be super easy and say, hey, these first three octets are going to stay exactly the same, 10.10.10. We're just messing with that fourth. Okay, so we have 10.10.10 dot, and then I'm going to take this into binary again. We'll split it down here, and of course this is the subnet mask, 255.255.255 dot, what is it, 192 or 128? 128. 128. Which I don't know why I'm writing that in decimal format. I should be writing that in binary, so you guys can see. 2, 3, 4, 5, 6, 7. Okay, so in binary we've got 1, 1, and 7 zeros. So I'm just gonna draw a line here to hopefully help you visualize. And so we're gonna do the logical ANDing process, which of course all these are 255. So we're just gonna copy this down here, 10, 10, 10. Then we're gonna do this logical ANDing. 0 and 1 is 0. And then these are all zeros, so I can tell from 0 and 0 and 1 and 0 are 0. So these are all zeros. 4, 5, 6, 7. All right. So now I can go do the math again and go, it's 10.10.10.0 is our network address. Okay. 10.10.10.0. Okay. What's our broadcast address? I'm going to turn all these bits on. That's 7 bits. So what is our 2 to the 7th? 128. Now the kicker there is one of those is all zeros. So we'll have 0 to 127. So to recap there, I can go and I can take this bit, that is the first, the rightmost bit, the first bit in our subnet mask now that we borrowed, and I can -1 and I will get the broadcast address. So, or I can do all the math here. I can do, this is 64, that's 32, 16, 8, 4, 2, 1. Add all those together, and they will add up to 127. I guarantee it. So, now we would go to the next network, and we could do that as well. And we would just have a 1 in this subnet column. And so we would start at 10.10.10.128. And we would end at 254. How do I know that? Well, actually, the 255 would be the broadcast. 254 would be our last host. And 129 would be our first host. That's because we only have 2 networks in this space, which means the rest of it's going to be taken up by the second network. And I know that everything ends with 255, so that's how we're going to do that. The reason we didn't go into the third octet is because we're not playing with those bits. We're only playing with the bits in the fourth octet, right? We didn't start with the bits in the third octet. We don't have those bits to play with. We can't. We're just going to start here and go on. First and last host address. So yep, we just add 1 to the network address for the first, 10.10.10.1, and 10.10.10.126 for the last, -1 from the broadcast. So hopefully that made sense to you guys. This did run a lot longer than I thought it was going to. Maybe I'll try again and make it a little bit shorter, but for now, hopefully this has helped you conceptualize subnetting and help you get the math down so that you can go and complete 11.6.6, and you can go and subnet in real world situations and impress crap out of everybody because you can multiply by 2. See you next time.